Hello everybody, welcome back to my channel and thank you for tuning in. Today we are gonna discuss how to build a power supply. We will be depending on the reuse of the reclaimed power supplies coming out of the Prolian DL580 G5 servers. Each of those power supplies are delivering 12 volts and up to 750 watts. You can get those power supplies from eBay for a very low price. I got 6 of them for around $50 including the shipping. So my idea is to connect multiple power supplies in parallel. However, adding power supplies in parallel requires some precautions for the connectivity, because if any of them is delivering higher voltage than the other, we may face some issues. One way to connect those power supplies in parallel is to build an interface circuit for connecting them and protecting each of them. The other way is to look how it was originally connected to the server. The Prolian server is supporting 4 power supplies in parallel. So the question is how it was connected. After some research, I found that there is a power supply backplane that is getting those power supplies attached to the server. This backplane is providing us with the protection circuit that we are looking for in addition to some other features. Today we'll be utilizing only the protection circuit in addition to the ability to turn on off each power supply individually without soldering anything to the power supplies directly. To power on the power supply, we need to short pin 33 and 36. After tracing on the board, we found that the 2 pins with the black dots are connected directly to pin 33 and 36. If we attach the switch to those 2 pins, we can power on the power supply through the board without the need of soldering anything to the power supply itself. This is really getting interesting. Just by using a $15 board, we can have up to 4 power supplies connected in parallel with protection along with individual on-off control. So let's get started by validating this solution. Here we are starting by soldering all the wires for the on-off switches for the power supplies. As there is no considerable current passing through those wires, we are using 24 gauge wires. The fully utilized board have the ability to deliver up to 200 amps at 12 volts. However, the lowest gauge that I have is 14 gauge, so I'm gonna use multiples of this. To test the board after soldering all the wires, I connected all the power supplies to the board. Now it's time to test the switches if they are functioning or not. Alright, that's encouraging. Let's move forward. As we have a lot of power that can come out of this power supply, then we need to add some features. What about adding a boost converter? The boost converter that I selected to add to this power supply will give us a variation of voltage from 12 volts and up to 90 volts. This boost converter has a maximum power of 1500 watts. However, the maximum input current shouldn't exceed 30 amperes. You can get this module from Amazon or eBay. I'll leave a link in the description. This module costs around $30, however you don't really need to add it. It's just an added feature. In this module we have 2 potentiometers. One for constant voltage control and the other one is for constant current control. So through one of them we can control the maximum output voltage, the other one can control the maximum current output. The plan is to extend the wires for those 2 pots and replace them with another 10 turns potentiometers. The voltage control pot has a value of 200 Ks, which I was not able to find for acceptable price. The only one that I found for acceptable price is the one that I got, and it's just 1 turn. That's fine, let me use it for now till I find a better replacement. The current control pot has a value of 5K, which was easy to find. I will also add a buck converter. A buck converter will give me the ability to reduce the 12 volts output of the power supplies to reach 1 volt. This module has a maximum power of 300 watts. However, it has a maximum amperage of 12 ampere. It has also two pots for constant current and constant voltage. Both of them has a 10K value. We have the same plan for this module like the boost converter. We will be extending the wires of those two pots and will replace them with a 10 turns potentiometers. In order to have the ability to measure the current delivered to any equipment connected to the power supply, we'll be adding this meter. This meter is depending on the Hall effect and can measure up to 100 amps. By using this, we'll not need to have anything between the power supply and the connected equipment. All what we need to do is to run the wire through the sensor and it will measure the current for us. Voltmeters will be added as well in order to know exactly the output voltage of the boost converter and the buck converter. I picked those cheap ones from Amazon. I got 5 for $10. However, I'll be regretting it later on, and you'll see. Now, as we know the contents of the power supply, it's time to create a container for it. The easiest way for me is to use my laser cutting machine. So I'll be creating this container out of 1/4 inch plywood, but I'll be using an 1/8 inch plywood for the dashboard because of the thread heights of the components that will be attached to it. And here it is after painting it. I think it looks decent. Here is what will be connected to the dashboard. We have the voltmeters, the current meters, and we have banana plugs for the power connection. Also, we have some spaces for the pots. And fortunately, I didn't forget to add power switches for the boost converter and the buck converter. And most important, we have places for the power switches of the power supplies. Now, it's time to replace the potentiometers. As everything is ready now, it's time for assembly. Everything is mounted to the base of the container, except for the buck converter, which is mounted to the side because of the space. The box consists of top and base with 4 sides with finger joints in between to mount them with square nuts and screws to hold them in place, while we are using a separator, and this separator is preventing the wires to get on the way of the power supply's slots. And finally, we are ready to power on. Let's test what we did. We just assembled everything within the box. We tried to fit in all the wires, and let's see. After hearing that sound, I was not so worried about it. However, after opening the box, I found that there were a short that impacted the board, and the board stopped functioning anymore. I had to replace it and do all the soldering from scratch. Let's have a second trial. No, not again. Anyway, that was all the suspense that we have. Now it should be working fine. Let's see it working. And let's have some tests. We are measuring the current through the negative wires coming out of the 2 poles at the top. Those wires are going through the sensor. I'm using this 100 watts LED light. I can control the current through the light intensity control. Finally it works. That's relaxing. Thank you everybody for watching and reaching this point with us. Thanks for your patience and looking forward to see you again in the next video.